Hello, everyone. So in this video, we will talk about the application of measures of association in research. When we talk of association or correlation, this is actually a measure of how your data are related to each other. It usually depicts the relationship between your independent variable or your X variable and your dependent variable and your Y or your Y variable. We all know in research that when we talk of the independent variable, this is usually the presumed cause, and the presumed effect will be your dependent variable. Now, to measure the association, it is usually expressed as a correlation of coefficient, wherein the direction and magnitude is being explored. Wherein, when we say direction, it is either positive or negative. When we say a correlation or association is positive, we know that as X increases or the independent variable increases, so as the Y variable will increase or the dependent variable will increase. Or if the X variable decreases, the Y variable also decreases. When we say an association is negative, we say that as X increases, okay, the Y or the dependent variable decreases. And it also happens vice versa. When the independent variable decreases, the dependent variable increases. Now, the magnitude refers to the strength of your relationship. It usually ranges from -1 to +1. Now, to determine the magnitude of the correlation, we can refer to this example or refer to this table. When we say the correlation coefficient is 0, we can say that there is no correlation or the correlation does not exist. If the value of your coefficient is from 0.01 to 0.09, we can say that the correlation is negligible. If the coefficient value is around 0.1 to 0.20, we can say that it is very weak. And if its value is around 0.21 to 0.4, we can say that it is weak or it has weak correlation. If your value falls from 0.41 to 0.6, we say that the values or the value or the correlation is moderate. Okay. And if the correlation is around 0.61 to 0.8, we can say that there is strong correlation. If your value falls from 0.81 to 0.99, we can say that there is a very strong correlation. And if the value is exactly 1, we can say that there is perfect correlation between your variables. Now, there are several tests that we can use when we try to determine the association between your variables. If your variables are at the interval or ratio level of measurement, we can use the parametric tests for association. No? If it's predictive, we can use linear regression. And if we're only correlating two variables, we can use linear regression. Now, we use linear regression if our question is to predict, to predict a certain outcome based on the data that trends your chart. Now, if you just want to explain or just to describe the correlation, you can use your Pearson product moment correlation if your values are scalar values, meaning it's set in the interval or ratio level of measurement. If you're correlating two variables and one is at the nominal level, okay, and correlate it to some scalar value, we use the point biserial correlation. If we correlate variables at the ordinal level, meaning it's in non-parametric test, we use a Spearman rank correlation. In this video, we will only talk about two measures of association, your linear regression and your Pearson product moment correlation, or your Pearson R. So let's have an example. Okay, before we proceed with the example, we will still follow the steps in hypothesis testing. As we have discussed in the previous video, we will first establish the null hypothesis, set the level of significance, determine the test statistic that we will use, and determine the critical value. And then the next step is to compute the actual value, which we will be using Microsoft Excel as our tool, and make a decision on that based on the computed value and interpret the findings. So here's an example for Pearson R. Suppose that a researcher wanted to know the correlation between the age and the IQ of students from kindergarten to college. The researcher gathers the data on the right. So here's the data for the age and the IQ. Is there a reason to believe that age is related to IQ? So if you will look at the last sentence, this will give you, or you can extrapolate here, the type of hypothesis based on direction. Based on this particular sentence, we can extrapolate that the hypothesis is non-directional because you are just looking only to the relatedness of the two variables, which are your age and your IQ. Now, if this is a non-directional hypothesis, we can say that we will be using two-tailed test. So using our 7-step formula or the 7-step in hypothesis testing, first we establish the null hypothesis, which is there is no significant relationship between the age and IQ of students. Now, we say that this is a null hypothesis because we establish, okay, we establish that there is no, or that these two variables are equal. The second step is to set our level of significance. As for this case, we set it at 0.05. Then we determine the test statistics that we will use, which is your Pearson R, and we will use a two-tailed test to determine its significance. The next step is to get the critical or set the critical value. And as we say, because we set, we will be arriving into a p-value, we set it the same thing as with our level of significance. Now, prior to this slide, I already computed on this value and found out that the R or the Pearson R is 0.87 and a p-value of 0.001. Okay, so to find out these values, I used Microsoft Excel. So to do this, we proceed to our Microsoft Excel, and first we plot our data on these columns. So one column for age and one column for the IQ. Now we set these parameters and label them so that we will not be confused when we type our formula. So to get the Pearson R, we just click this cell and press equal sign and type the word Pearson. Okay, and select this function. Now, the syntax of the formula is this. We use Pearson, then it will prompt you to select the first array of your data, which is your X variable, and your Y variable for the array 2. Based on the problem, the X variable is your age, and the Y variable is your IQ. So we first select our age, then separate it with a comma, and then select the second set of data, which is for our IQ. And then press enter. You will arrive with a value of 0.87 or 0.867110078. We reduce it to 2 decimal places. So it's around 0.87. Now, to get the p-value, we have to identify the frequency, the t-statistic, and your degree of freedom. To identify the frequency, we just count this data. To get this, we can use the formula. We can manually count it, or we can use the formula count. So we type equals, and then type the word count, and open parentheses, and highlight just one column to count all the data, or how many data is this. So upon counting, we arrive at 10. So let's manually check if it's correct. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So therefore, Microsoft Excel counted this whole set of data as 10 sets of data. The next step is to compute the t-statistic for your Pearson R. So to do this, we refer to this formula. T is equal to R, which is your Pearson R value, times the square root of n minus 2 divided by the square root of 1 minus your Pearson R value squared. So to type it in our Microsoft Excel, we just type equal sign, then click the R value, multiplied, so you use the asterisk sign, by the square root. So the formula for square root is SQRT. And then open parentheses, select the number, which is your n, minus 2, and close parentheses. So this is the first or the upper part of your formula. Now we will continue it with the lower part by dividing it. So we put a slash, which signifies division, divided by this part. So to get this formula, we type the square root of 1 minus R, and then use this symbol to raise your R value to 2, or to make it a squared value, and close parentheses. So once you're done with the formula, just press enter, and you will get this value. The next step is to get your degree of freedom. Your degree of freedom is actually this part of your formula. So it's n minus 2. Therefore, you type there equal sign minus your n value minus 2. And then press enter to get 8. Okay, to get 8. So to get the p-value, all right, for this one, we just type the t-distribution formula, which is t-dist, open parentheses, select the x value, which is in this case your t-statistic value, which is this one, comma, select the degree of freedom, which is 8, comma, and since we have established in our third step that we will use a second or a two-tailed test, we type there 2. Then close parentheses and then press enter. You will get a value of 0.001. So that's why we arrive at an R value of 0.87 and a P value of 0.001. Now that we know that the P value, which is this one, is less than the level of significance, we reject the null hypothesis. Therefore, we can say there is a significant, very strong, because the value is 0.87. Positive means that the value is in the positive side. So it tells you the direction of your relationship. So therefore, it's a positive relationship between the age and the IQ of the students. Now let's go to linear regression. Now in linear regression, you are actually looking for or predicting the outcome of your variables based on the observations that you get. Okay. Now, Suppose we have the same data as we had before, but this time we want to know, or the researcher wants to know, if there's a reason to believe that the age can predict your IQ, given the set of data that we have. Okay? So when we use linear regression, first and foremost, we establish the null hypothesis. So when we establish the null hypothesis, it's the same, no? When we use your when we use your null hypothesis for Pearson R, because it's looking or still looking for correlation or relationship between your variables. We set the level of significance at 0.05 and say that and establish the test statistic as linear regression. We say two-tailed because we're still looking only if it predicts. Okay, we do not say it as whether it is positively predicting the IQ of students based on your age. No, we're not saying it that way. No, the question says that is there a reason to believe that age predicts your IQ? So it's a non-directional hypothesis. Therefore, we use a two-tailed test. Now, we also set our critical value at 0.05 because we will be using the p-value in our statistical test or hypothesis testing. Now, when you compute for the p-value or for the regression, for the linear regression, we always identify the least squares regression line by the formula y equals a plus bx, where y is your dependent variable, a is the y-intercept or the value of y when x is equal to 0, and b being the slope of the line. Now there's a lot of way to compute for this. Okay, you can use or you can compute it manually using your data. Okay, or you can use Microsoft Excel to determine the least rel or the least squares regression line. Okay, to do this, again, we plot our data in Microsoft Excel. Okay, one column for the age and one column for the IQ. Now that we have plotted our data, we identify first the least square regression line by plotting these values in a Cartesian plane. So to do this in Microsoft Excel, just highlight the two variables, click Insert, and choose this chart type. So to plot this, we use a scatter plot diagram. So we choose this particular button to plot our values in the Cartesian plane. Now, to know the least rel automatically, just click this portion, the quick layout, and choose this layout. All right, you can notice that it has a symbol of f of x, which tells you that this will give you a formula, okay, or your least rel. So when you click this, it will give you this value. So I'll zoom in. So the least rel formula is y is equal to 3.6773x plus 55.486. This is your A or your y-intercept. And this is your slope of the line or your B. And this is your x value, which we will be using later on to predict the variables. So knowing our least rel formula, we transfer it to our solution. Now, when you submit your papers, you have to make sure that you present the plotting of your variables in the Cartesian plane. So you have to show this and show the slope of the line and your least rel equation. Now, how to determine whether this particular literal is significant or not. We go back to our Microsoft Excel. Okay, as we go back to our Microsoft Excel, we go to our data and choose data analysis. When we choose data analysis, we click the regression and then click OK. Now we select the variables or the input for the Y range. So we click this one and select this part for the Y variable because we all know that IQ, or we have established before that IQ is the Y variable or the dependent variable, and your X variable, which is your age. Selecting this part. Okay. So after selecting your X and Y input, all right, we leave this as it is. So we select our output range, which should be around here, or we should start here, or something like here. Okay, and then click OK. Automatically, your Microsoft Excel data analysis toolpack will generate this output. Now, to know whether our literal is significant, we look at this column, the p-value. Okay. Now we see that our p-value is at around 0.002 for the y-intercept. Okay. And for your x variable, it's around 0.001. So we can say that our literal or our computation is significant. All right. So we can say that the p-value is less than the level of significance. Therefore, we reject the null hypothesis. Therefore, we can say that age can predict the IQ of your students. So if it really can predict the IQ of your students, how do we know the value of Y if we are given a certain age? Let's say, for example, how we will know the value of our IQ if we are given a certain age, like for this example, 50. So we just substitute the X here with the value that we want to predict the IQ of our student. If it's 50 years old, we replace X with 50 and use this particular formula that we have found out. By computation, we will know that it is around 239.35, or we can say that the IQ is around 239. That's the end of my discussion for measures of association. Thank you very much and have a nice day.